At chapter 7. So starting chapter 7 is exponential functions. Okay, and then we'll get into logarithmic functions, which is the inverse of an exponential. So starting off here, have you ever received a message that tells you to forward it to 5 friends? If each of those 5 friends then forwards it to 5 of their friends, who each forward it to 5 of their friends, the number of people receiving the message is growing exponentially. Have you ever actually received one of those? Yeah?
Yeah.
You know what it's talking about?
Last year I did.
That's cool.
Pretty weird.
So that will grow exponentially. It will have a function that is 5 to the x because you have 5 people forwarding it to 5 people, forwarding it to 5 people, and then that x is however many times that it gets forwarded. So we're going to look at exponential growth today and tomorrow. Not tomorrow, Monday. Okay, so a function like y equals 5 to the x power, where the base is a constant and the exponent is the independent variable, is an exponential function. One type of exponential function is exponential growth. An exponential growth function is a function of the form f of x equals b to the x, where b is greater than 1. So b has to be greater than 1. That's that base value. So 5 is greater than 1, so you have an exponential growth. If it was less than 1, you would have a decay. Okay, so if it was a fraction, that would be exponential decay. And we'll get into that next week after we go over exponential growth. So the graph of an exponential function has an asymptote. I know we've talked about asymptotes before, I believe. What that is, that's a line that the graph of the function approaches. Okay, so it's a line that the graph of the function approaches. So it will never, your graph will never cross that line. Okay, it'll get closer and closer and closer to it, but it will never actually cross that line. So our exponential growth functions do have that asymptote. So the parent function of our exponential is b to the x. Okay, it looks like this. Whenever you plug in 0 for x, you should get 1. So if you have any number raised to the 0 power, it's always going to be 1. Doesn't matter what the base number is. Okay, so this one, its asymptote is the x-axis. So if you kept plugging in negative numbers for x here, it would be a smaller and smaller fraction, but it would never actually hit 0, and it would never actually be negative. Okay, so wherever that asymptote is, that's how you can find the range of your function. So we're going to go through some examples of graphing these. So our first example is y equals 3 to the x power. Okay, and then we want to state the domain and range of the function. So step 1, make a table of values. Okay, so I want a couple negative and a couple positive. So I'm going to plug in -3, -2, -1, 0, and then 1, 2, and 3. Okay, so I'm plugging in those values for x in my function. So if I plug in -3 for x, that negative flips it to the denominator, right? So I would actually have 1 over 3 to the third. Okay, 3 to the third is 27. So I would have 1 over 27. Okay, so a small fraction there. Okay, same thing with -2. Again, if I plug in a negative, that flips it to the denominator. So I would have 1 over 3 squared. Well, 3 squared is 9, so I would have 1/9. then negative 1. Again, flips that to the denominator. So I have 1 over 3 to the first, which is just 1/3. Okay, so if you have a negative exponent, it creates that fraction. Questions on that? All right, now if I plug in 0 for x, what should I get?
0.
No.
No.
If I plug in 0, what do you get? I said it earlier.
3.
Not 3.
1.
1. So if you have 0 as an exponent, that value is always going to be 1. Okay. Next, plugging in 1 for x. Okay, that will give me 3. Plugging in 2 for x, I would have 3 squared. 3 squared is 9. Plugging in 3 for x, I would have 3 cubed. That's 27. Okay, step 2 is to just plot my points on the graph. Okay, so I have negative 3, so go left 3 from the origin. And then I have 1/27, so a fraction really close to that x-axis. Okay, next I have negative 2 1/9. So left 2, again, fraction really close to the x-axis. Okay, then I have negative 1 and then 1/3. So negative 1 up to 1/3. Then I have 0, 1, 1, 3, 2, 9, and 27 isn't on your graph, so you don't have to plot that one. Okay, but you can kind of see how each of those points makes that exponential parent graph, just like it did here. Okay, you see that curve. Okay, and we have that curve with all of our points. So again, you have an asymptote. Your asymptote is the x-axis. So when you draw in your line should not cross the x-axis. You can draw it really close to the x-axis, but it should not cross it. Okay. Can you kind of see that line? So you can see how it grows exponentially. So it starts really small and then all of a sudden it goes straight up. Okay, last step is to state the domain and range. Okay, for our domain, can I plug in any number for x? Do I have any restrictions when I plug in a number for x? So I can plug in negative 10. I can plug in positive 100, right? Okay, so I can plug in any number for x. So this is all real numbers. Okay, and I'll just use the symbol for all real numbers. You guys did that last year, right, with Mrs. Dobbins? Okay. Okay, then our range. Our range is our y values. Okay, so what kind of y values do we get? Well, y values is along this axis, but they don't go below the x-axis. So that means our y values, we'd have y such that y, they have to be greater than 0. Okay, so you'll notice all my y values are above that x-axis. That means they are greater than 0. Now, if I had a line that was down here and then went up, I would say it has to be greater than negative 3 or something like that. Okay, so wherever your asymptote is, that's where your range gets cut off. Make sense? All right. Next one. I want you guys to do this one. Okay, same thing, except now you have 4 to the x power. So we'll plug in a couple points. Plot those points and then tell me what the domain and range is of that function.
I did the extra credit too.
Oh, good job.
Huh?
I'm reading the Crucible. You're reading? You watched the movie on test and was rereading it because you had nothing to do.
Are you doing this problem?
What problem?
The one I asked you to do.
I don't know how you got those numbers.
Just plug in numbers.
Pick any number in the world.
Well,
Like, where do you get,
plug in like these numbers that
where
I
do you
did.
get these?
I just plugged in numbers. But I can plot points on my graph.
So does it matter what I pick?
White ties.
Well, plug in some negative and some positive.
Some positive. Yeah, I have one positive.
Well, I have these three positive as well. I just didn't have enough room to send a graph.
Oh. -2, -3.
Yeah.
1, 2, 3.
Yeah, look at that. Plug those into the function.
Should be 4 and 16.
Where is Seth today?
Back here.
I know that, but where is he? All right, so I plugged in -3 through 2. No, don't erase yours. You can plug in -2 through 3.
Yeah, but you did -3. You knew
You
that.
you don't have to do that one. You can't. You can barely plot that anyways, and you can't even plot 3. So relax. You can keep yours. Doesn't have to be exactly like mine. Okay, so I'm gonna plot each of these points. So -3. This dot should be really close to the x-axis since it's 1/64. -2, again, 1/16 is pretty close to the x-axis. -1 is 1/4. A little bit further away, but not much. And then 0 should be at 1. 1 should be at 4. And then 2, I don't think there's 16 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's not. 14, 15, 16. Somewhere up here. Okay, so then all you want to do is connect your points. Again, not crossing the x-axis, but getting close to it. Okay, so here's my exponential function. Then my domain. Okay, again, your domain, I can plug in any number for x, and it will give me a value. So your domain is all real numbers. Then your range, okay, those are y values. What does y have to be greater than for this one? 0. Okay, so your asymptote is at 0 here, so that's what y has to be greater than. Okay, questions on the parent functions? All right, so our parent function is b to the x. Okay, so we can transform our graphs using a, h, and k like we had been before. Okay, do you remember a, h, and k, right? So this is our form for exponential. We have a times b raised to the x minus h power, then plus k. Now your h value, that's this one right here, will move your graph left and right. Okay, so that's your horizontal transformation. Your k value will move your graph up and down. Okay, these are the same as when we worked with them before. H moved it left and right, k moved it up and down. Okay, and then a is your orientation or shape of your graph. So if you have a less than 0, so it's negative. So if your a value in front of your b value is negative, it is going to reflect it in the x-axis. So that means it's going to go down this way instead. Okay, so that's if a is less than 0 or negative. This is the form your graph would take then. Okay, so it'd be reflected in the x-axis. Okay, that's what that means. Now if the absolute value of a is greater than 1, you're going to stretch out your graph. That means it's going to get longer vertically. If a is a fraction, so it's between 0 and 1, it's compressed vertically, so it's going to kind of shrink down a little bit. Your points are going to get lower than what they once were. So today we're only going to go over one of these transformations. So that transformation is plus 1 on the outside here. Now I highlighted that blue because it is a vertical translation, because you're moving up 1 unit. Okay, so that is a k value. This 2 out front is not a. Okay, that is b. Okay, if you see an a value, it'll look like 2 numbers being multiplied together. Okay, so you'd have an extra number out front if you have an a value. But b is going to be a single number, and it's whatever's raised to the power. So just like before, we're going to pick points, find our y values, plot the graph, and then state the domain and range. So our x values, again, I'm just going to use -3, -2, -1, 0, 1, 2, and 3. All right, so if I plug in -3 for x here, okay, I have 1 over 2 cubed. What's 2 cubed? 8. 2 cubed is 8. 2 times 2 times 2 is 8. So I have 1/8 plus 1. 1/8 plus 1. You can divide this if you want. So 1 divided by 8, and then add 1 to it. Okay, that is about, or is 1.125. Okay, do the same thing with -2. So 2 raised to the -2 power, that would be 1 over 2 squared. So 1 over 4, then we're adding 1. So I'm just using my function here. Okay, so I did 1 over 2 squared plus 1, 1/4 plus 1. Okay, that's 1.25. Okay, then plug in -1 for x. Okay, so we have 2 to the negative first power. So that would be 1 over 2. then plus 1. Okay, that's 1.5. Okay, then I have 0. If I have 2 raised to the 0 power, what do I get?
0.
No.
What did you say?
2 raised to the 0 power. 1.
So 2.
So I have 1 plus 1, that's 2. Plug in 1 for x, so I have 2 to the first, that is 2, plus 1, so I get 3. Plug in 2 for x, so I have 2 squared, that's 4. So I get 5. And then 3,
10.
not 10. 2 to the third is 8, plus 1 is 9. Okay, so I have negative 3, 1.125, negative 2, 1.25, negative 1, 1.5, and so on. Questions on how I got each of those points? I'm just plugging in that x value into the equation. All right, so now I'm going to plot my points. So I have negative 3 and 1.125, negative 2, 1.25, negative 1, 1.5, 0, 2, 1, 3, 2, 5, and 3, 9. Okay, you can still see that pattern. Now, where do you think this asymptote is? Remember, we had an asymptote on all of our other graphs. If our asymptote was at 0 for our parent function and I moved the entire graph up 1, where should our asymptote be? At what? I moved the entire graph up 1. Where's the asymptote? At 1. Okay? So your asymptote here is going to be at 1. So when you're drawing in your line, it shouldn't pass 1. Okay? It should get close to 1, but it shouldn't pass it. Okay, so this is my exponential. Next, I want to state my domain and range. So for domain, can I plug in any value for x? Am I able to plug in any value I want for x? Yes.
Yes.
Okay, so that was all real numbers.
All real numbers.
Now your range is not greater than 0 this time.
So why?
It's greater than what?
1.
1. So if you see this k value, that affects your range and your asymptote. So if I say you're going down 1 instead of up 1, your asymptote would be at negative 1, and then your range would have to be greater than negative 1. Okay, does that make sense? So you just have to plug in those points.